All right, we're on day 3, people. How exciting is that? Today we're going to talk about some nice Pythagorean theorem and the triples, which are going to be awesome for us. It talks about finding some values right off the start. So again, we have our good old a squared plus b squared equals c squared, where we know c is going to be across from our right angle and the largest side. So that value is c, this value is c, and that value is c, right? The right angle points to it. So we can find the missing side using Pythagorean theorem, right? So we got 3 squared plus 4 squared equals x squared. Then we would get 9 plus 16, and that is 25 is equal to x squared. And then we take the square root of both sides to get rid of x, or get rid of the square, so we're left with x is equal to 5. So we found 1. Let's look at the next one. Again, now I'm trying to solve for a or b, so we'll call that a. X squared plus 8 squared is equal to 10 squared. I have x squared plus 64 is equal to 100. I'm going to subtract 64 from both sides, giving me x squared is equal to 36. And then I'm going to take the square root, so I have x is equal to 6. Last one over here. So now I have 3 root 3 squared plus x squared equals 5 root 3 squared. Good radical review here, so we're going to square both numbers, so I get 3 squared times the square root of 3 squared plus x squared equals 5 squared times the square root of 3 squared. So 3 squared is 9 times square root of 3 squared is just 3 plus x squared equals 25 times 3. 27 plus x squared equals 75. Subtract 27 from both sides. So I would get x squared is equal to 50. 25 would be 50. 48, sorry. X squared is 48. We're going to take the square root of both sides. So I get x equals the square root of 48. But we can simplify that, so we'll break that down, and I get 24 and 2, and then I'll do, 6 and 4, and I'll break those down into 2's, and I'll break this down into 3, 2. So I get one pair of 2's, and I have another pair of 2's, so this is going to be 2 times 2, so I get 4 root 3 for my missing side. Wow, that's a lot of algebra review. Love it. All right, so what can we conclude about these triangles? Well, let's look at these. I've got 3, 4, 5, with 5 being my hypotenuse, the largest side, right? So 3, 4, 5. Then I have a 6, 8, 10. Well, how do I get from 3 to 6? I multiply by 2. How do I get from 4 to 8? You multiply by 2. And look at that, 5 to 10, you multiply by 2. So these guys are all proportional. Side, 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 similarity, it's happening. All right, so let's look over at this triangle. So again, 3 root 3, 4 root 3, 5 root 3. So multiply all 3 sides by root 3. Again, side, 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 similarity. So we know that these triangles have the same multiple. And that base multiple is a 3, 4, 5. That's awesome. We have a whole bunch of families that are like that. So let's list them. All right, there's endless amounts of families, but these are the 4 that we're going to talk about the most in this class. So we have the 3, 4, 5, which we just worked with, right? Then 5, 12, 13, 8, 15, 17, 7, 24, and 25, right? So these are all the most common families, or triples, as we're going to refer to them a lot. And there are, again, more, but these are the most commonly used ones. So if you can memorize these bad boys and use them, it will make you a much happier person, right? These are going to be shortcuts, essentially, if you can recognize that. So less Pythagorean theorem, more shortcut. We like that. So again, we're going to look for the missing side. Find the x using what we know about triples. All right, so if we had to use Pythagorean theorem right now, we'd have to do 3 over 7 squared, 3/7 squared, plus 4/7 squared equals x squared. You're going to get fraction over here, and plus another fraction, and then we got to take the square root of the whole fraction, right? Or we can recognize 3, 4, which means this is going to be 5/7, right? 3 over 7, 4 over 7, 5 over 7. This is a 3, 4, 5 family. So your work is telling us what family is from and then giving us the missing piece. Much easier than having to do Pythagorean theorem. All right, let's see if we're getting the hang of it. So we're finding the missing side based on what we know. Okay, well, if I look at my list of families, I know 10 and 26 isn't one of those families. However, 10 and 26 can be reduced, right? I can take out 2 from both of those. If I divide 10 by 2, I would get 5. If I divide 26 by 2, I would get 13. 5. 13 is the 5, 12, 13 family. So we just doubled the 5, 12, 13 triangle. So what is my missing side? Well, I had 10, so I was given the 5 side. I had 26, which is my hypotenuse side, so doubled the hypotenuse. So x is going to be 12 times 2, or 24. Right? So again, we're looking for multiples of the family, not just specific families. So we have the multiple of the 5, 12, 13 family. So this is all multiplied by 2 to give us that triangle. All right, let's keep going. So now I have the another triangle. Again, 16 and 34 are not one of our families, but let's divide both by 2 because they're even. That seemed to work for us before. So I have 8 over here. I have 17 over here. So 8, 17, 15 family. All right, so 8, 15, 17 is a family, which means we're in a multiple of 2, right? So 8 times 2 gave us 16. 17 times 2 gave us our hypotenuse of 34. So we're going to multiply 15 by 2 to give us 30. All right. Pretty nice trick, right? All right, so it says find the diagonal of a rectangle whose dimensions are 9 and 12. So I've got a rectangle. We know rectangles have a right angle, so here's the right angle that we have. Diagonal is what we're looking for, so that's going to be our x. It has a dimension of 9 and 12, so I'm going to assume that the short side is 9 and my longer side is 12, according to my picture. So we could do Pythagorean theorem, right? 9 squared plus 12 squared equals x squared. Solve for x. Or we can look for one of our families. Again, these are multiples of 3, so I'm going to divide both sides by 3. I get 3 over here and 4 over here. So we've got 3, 4, 5 family. So this is a 3, 4, 5 family, which means if I'm looking for my missing piece, I mean to multiply the missing piece by 3. So we did 3 times 3 to get to 9, 4 times 3 to get to 12. So 5 times 3 is going to give me my diagonal. So 15 centimeters, right? Nice tricks knowing those families or those triples. All right, we just need to be really careful here, right? So here I'm looking at a picture and it says danger, thin ice. Why is that thin ice? Well, let's look. So I've got 3, 4, so we want to say 3, 4, 5 family. But what do we notice here? 4 is across from my right angle. That's my hypotenuse. So this cannot be 5 because then a leg would be longer than the hypotenuse, and that is not possible. So this is not the 3, 4, 5 family because my hypotenuse is not 5, right? So we actually have to do Pythagorean theorem on this one to solve it. So you get 4 squared for C is equal to 3 squared plus x squared. So you would then have 16 over here and 9 plus x squared. We're going to subtract 9 from both sides. So that would give you 7 is equal to x squared. So the square root of x x is equal to the square root of 7, and that cannot be simplified because it's prime. So just be careful, right? We're going to try and trick you, but you need to be smart and know that the hypotenuse has to be the largest side. All right, so let's take a look at a couple of examples. So see if you can try and work these guys out on your own. We already went through one of or both of them in this 2 slides, so it shouldn't be too difficult. Come back and check with me. So I've got a right triangle here, and so I know 2 legs, right? And I'm trying to solve for my hypotenuse, which is across from my right angle. 12 and 9 are multiples of 3, so let's divide both sides by, or all sides by 3. So it's the 3, 4, 5 family, which means I'm divided by 3, so we're going to multiply by 3 to give us our missing length. So this side is 8, 15. Now I'm going to look at another right triangle. Now I have both of my legs, 8 and 15. I'm looking for my hypotenuse, which is 17, because this is the 8, 15, 17 family. All right? Pretty neat trick, knowing those families. All right, go ahead and do the ticket to leave, and then you should be able to do your homework. Again, you don't have to use the triples. You will not be penalized if you want to do Pythagorean theorem over and over again, but it's really nice if you do. All right, so we're looking for the missing side. I'm looking at 48 and 20, which are definitely not a family. However, if let's divide both sides by, I guess I'll start with 2. 2, so I get 10 over here and 24. That's not going to work. But let's keep going. Oh, I should have probably done 4, huh? So we're going to divide by 2 again. I'm going to get 5. I'm going to divide this by 2. I'm going to get 12. So we're actually looking at the 5, 12, 13 family. There we go. And if this is the 5, 12, 13 family, I actually ended up dividing by 2 and then dividing by 2 again, right? So I'm actually looking at a multiple of 4. So 12 times 4 gives me 48. 5 times 4 gives me 20. So then 13 times 4 will give me 26, plus 26 is 52. I can do math and I love it. All right, hopefully that makes sense to you guys. If not, go back, look through the videos again, or pop in and see us. Have a good day.